So permutations, what are they? That's what we're going to get into. So we're talking about how many different ways can you arrange items, okay? Now, sometimes the numbers are small, it's super easy, we can just multiply it together. Other times we're going to use that permutation function in your calculator. So just like it says, we're looking at an ordered arrangement of objects. Now, keywords here, and I know it's super dramatic as we always are, you're going to keep seeing the word order. Because eventually, Monday, order will not matter. And then it's a combination. So you're going to use a different function in your calculator. Today, the order does matter. So if you're looking at, like, let's say the first three letters in the alphabet, A, B, C, that is a different arrangement than CDA or BAC. So we're looking at all the different ways you can arrange things today. So that's what we're going to be working on. So here we go. How many, very wordy today. I know some of you that love the words. Probably not going to love it, but here we go. So in how many ways can 6 jokes be delivered if a knock-knock joke has to be told first and a dad joke has to be told last? Okay. So, and you'll see this is kind of how I play on all of these. I kind of look at how many total items we're talking about. So 6. So I'm going to put 6 different blanks down. 2, 3, 4, 5. 1 to represent each joke. Okay. Now, it says we have to do a knock-knock joke first. So that means I only have one choice to put in the first joke slot. I have to tell a knock-knock joke. Okay, we have to tell a dad joke last. So in the last slot, I only have one style of joke that I can possibly tell, the dad joke. Now, the middle numbers. So here's the thing. We are telling 6 total jokes here, and I already have put in place the first one and the last one. So how many jokes are left to be told? 4. So now I told that joke. Now how many jokes are left? 3. You get the idea. 2. Now this is a throwback, of course, to the very beginning. We started all of this stuff. We're using that fundamental counting principle, which sounds very fancy, where we're multiplying all of our different options together. So, I mean, really, let's be smart on our calculators. Do you need to really put the 1? No. So just figure out what's 4 times 3 times 2 times 1 for me. So you have 24 different ways to arrange those jokes. This is what we're doing today. Okay? It is easy. It is easy. That's why I said somebody asked if we had homework. And I said, well, technically, yes, but I think you could probably get it done in class. Okay? Okay. So 7 different polo shirts. So I'm going to put 7 blanks. 2, 3, 4, 5, 6, 7. On a shelf at display at the Gap. How many ways can Tom do this? Well, notice that no restrictions about what shirt has to go where. We can put them however we want. So to put the first shirt, I've got 7 total to pick from. So I arranged one of the shirts. How many are left to put on the next spot? 6. You get it. Now what? 5, 4, 3, 2, 1. You got it. And we're going to multiply that together. I'm going to give you a sec to punch that in. You get kind of a large number. Yeah. Now, the next thing we're going to talk about is we could have actually, I think, done this a little simpler in our calculator. Instead of me having to actually type 7 times 6 times 5 times 1, we can use what we call a factorial. That is this crazy looking exclamation point. In the world of math, we call it a factorial. So all it is you start at your number, and of course we go down to 1. So I could have, in my calculator, instead of actually typing all of that in, I could have done 7 factorial. So I'm going to start using that a little bit just to save me some time, especially if you have, a large number. Like I don't want to do maybe 12 times 11 times 10. Like that's kind of obnoxious. So let's look at the next one here. How many different ways can 7 children be arranged in a line? Well, kind of same idea here. 2, 3, 4, 5, 6, 7. So I have 7 kids to pick from now. 6, 5, 4, 3, 2, 1. But we're going to be smart here. I'm not punching that in. We're going to do 7 factorial. So on your calculator, all I'm going to do is 7. And remember, all of this stuff is in that math menu over in probability. And you can see the factorial is number 4. 5,040. So it's up to you how you want to punch them in. I don't care whatsoever. You pick it. You get the same thing. So just to kind of show you that. Just put the answer on here before we flip it over. Okay. Now, still, of course, multiplying, but we're going to talk about in your probability menu this permutation function. So if you have a group of objects, but you're only using R of them at a time. So what does that mean? That's very wordy, I'm well aware. So that means instead of maybe arranging all 7 kids like the last problem, well, maybe we have 7 kids, but we're only going to line up 4 of them for pictures. The other 3 aren't doing it, okay? So we're looking at picking a certain amount from the total group. So that is this. Now, here, of course, is the formula, but your calculator will do it just straight off of this for you. You're not going to have to do anything. So just a couple things to throw on here for you. The first subscript is always the total amount of items that you have to pick from. And then the second subscript, the R, is the number you're arranging. So you just have to kind of keep your subscripts straight, so to speak, okay? And I've already showed you, I'm going to use the function in the calculator. I'm going to show you both ways to do it by hand or to use this in your calculator. I don't care how we do it, as long as we get the answer. So consider the letters A, B, C, D, E. How many distinct ways can 3 letters? So this is what we're talking about. I'm not arranging them all. I'm only doing 3 of them, okay? If repetition, of course, not allowed. So we're only doing 3 letters. So I only put 3 blanks. Now, this is easy. Just do a quick count. How many total letters are there to pick from up there? 5. So I have 5 letters to pick from. Now 4, now 3. So I don't even think we need a calculator to multiply that. What's 5 times 4 times 3? 60. Okay, if you want to do it calculator style with the formula, and I'm going to punch this in too. So your first subscript is the total number of things we had to pick from, which was the 5 letters, but we're only arranging 3 of them. Okay, so in my calculator, and it kind of depends what model you have. This one, I have to put the first subscript in first. So I'm going to put the 5 in. Then I go to math menu, over to probability, number 2. And you can see it puts in the second little square there for my second subscript, which is 3. And we get 60. Okay, so I don't care how you do them. If you just like to multiply the numbers or you want to use the permutation function, that's totally up to you. But some of the calculators, when you hit it, and again, I think the model on this is just a little different than some of the newer ones. I went too far. You can go to that, and it puts the boxes for each subscript, and you can type them in that way. So however you want to do it, you'll get it. Okay? I kind of like this stuff. All right, I'm going to put equals 60 here. And we'll get to the next one. All right, you are among 8 people forming a skiing club. Sounds fun. Collectively, you decide to put each person's name in a hat to randomly select a president, vice president, secretary, and a secretary. How many different arrangements or permutations are there? So, of course, counting principle, we're not using our formula. So, how many total people are there that we are selecting from? 8. And how many are we actually going to select? 3. So, I'm going to do 3 blanks. Lila, did you guys have a question back there? Oh, okay. Because we're not chatty at all. And of course, now we're down 1 to 7, and then 6. That you probably want your calculator for. What's 8 times 7 times 6? 336. And again, I'm just showing you both ways here in the notes. You don't have to do both ways for every problem. Now, if I want to use the formula, there's 8 total to select from, and you're arranging 3 of them. If you punch that in, you will also get the 336. And like I said, you don't have to do both styles on every single problem. I'm just showing you pick your poison. Let's read the next one and see what we want to do. Okay, 5 singers are to perform in a local club. One of the singers, of course, one of them has to be a pain, wants to perform on the night. How many ways can the singers perform? So somebody has to be last. I mean, gosh, somebody's got to be difficult. So I'm thinking about my 5 singers. So I'm going to do it counting principle style first, where I just multiply the numbers. I'll show you the formula if you want to do it that way. Now, here's the tricky part on this one. One of the singers has to be, and I'm a little off the screen there, has to be last. Okay, all right. So let's say I'm going to pick on poor Addie. She's going to be the difficult one today. She has to be last. I only have 1 person to pick from for that. Now, rest should be easy. So I already put Addie there. I can't pick from her anymore. How many people do I have to pick to go first? 4. Now, 3, now 2, now 1. Okay, multiply that out for me. 24. Now, if you wanted to do it formula style, this is the tricky part on this one. Usually I ask you what the total is first, but I'm going to ask you that in a second. I'm going to first ask you this question. Here's why this is a little tricky to do it with the formula. Because how many singers are we actually arranging? Well, these guys. Why didn't I include the last one? It has to go last. I can't reorder that last person at all. I have zero choice on that. It has to be in the last spot. So if I wanted to do it permutation style, there's 4 of them that we are arranging. So if you punch that in, you get the 24. So that's where it gets a little tricky, is when they give you these very specific, oh, somebody has to be first, somebody has to be last, somebody has to be in the middle, whatever. Then it gets a little tricky to do your permutation because you're not actually putting that in your arrangement. That's the only thing I don't like about this. It's a little dicey, okay? All right, this is the last thing I'm going to show you. This is super easy. It's kind of a pain to type in the calculator, if we're going to be honest. So the number of distinct permutations, okay? Here's the thing. If, of course, we have some identical objects. Now, notice the exclamation points, of course, are factorials. So the first thing I'm going to do, I'm just going to count the total number of letters, objects, whatever it is that we are arranging. The denominator are your duplicates, is your identical different items. So you're like, what is all this craziness? How many different ways can the letter in the words Tallahassee be arranged? Good thing this isn't a spelling test. Okay, first question for you. Count for me. How many total letters are in the word Tallahassee? 11. Okay. Now, to figure out the arrangements, because you can see in the word Tallahassee, we have some repeated letters. Those are going to go in the denominator factorial style. So first thing that jumps out to me, of course, we have repeated L's, right? How many of those are there? 2. What other letter is repeated? So A's. So how many A's? 3 A's. Kind of hard for me to circle those. All right, what else is repeated? 2 S's. And what else? 2 E's. I need a longer fraction mark. So that is what you have to type into your calculator. Now, I don't know if I try to type this all in one giant step. I would start with the 11 factorial. Give me the 11 factorial first. That's a big number. Got it. Can we actually, here's a fun question. Can we actually read that number? 39,916,800. Okay, got it. All right, do the bottom. What's 2 factorial? And you can literally just type this all in just as it appears and it will give it to you. These are just obnoxious to punch in. 48, divide it out for your final answer then. There we go. Now think about that. That's how many different ways we can arrange, we can scramble up those letters in the word Tallahassee. How awful would that be if we had to write that out? That would be awful. Okay, awful, awful. I'm going to say it one more time. So again, we're just finding the total number of ways. Last one and we're done, people. It's that easy. 6 horses, of course I had to make this problem. 6 horses are entered in a race. If 2 horses are tied for first place and there are no ties among the other 4 horses, how many ways can the 6 horses cross the finish line? Okay, sounds wordy, but I promise it's simple. Easy question. How many total horses are there? 6. So the total, of course, always goes on the top. Now, we do have a quote-unquote repeat happening, the tie. How many horses are in the tie? 2. Calculate that out. Final answer, 360. I had to do a problem about horses. Got it. that is it, my friends. Okay, so on Monday.